Good morning. Today we are looking at arithmetic and geometric sequences. So a sequence is a list of numbers or a pattern that you're going to follow. Some of them are arithmetic. Arithmetic is a fancy word for meaning we're adding or subtracting, like arithmetic. And then later we'll look at geometric sequences, which you can see this is has an exponent in it, so it's multiplied many times. So this is when we have multiplication or division. So here at arithmetic, or adding and subtracting, this is actually in the form y equals mx plus b. Because in an arithmetic sequence, if I were to plot some points, they would form a straight line. And you guys have looked at tables before that look something like this, -2, -1, 0, 1, and 2, where, we might be at -1, then we might be at 1, then 3, then 5, then 7. This second row is what we're looking at for the pattern. Every single time, we're going up by 2. So I know this is an arithmetic pattern because it's a nice straight line, and we're having the same pattern repeated over and over. So later, when we get to geometric sequences, these ones are going to be multiplied each time. So just like when we did growth and decay functions in chapter 8, that's what geometric sequences will look like. So first, identify an arithmetic sequence. Tell whether the sequence is arithmetic. If it is, find the next two terms. So let's look here. From -1 to 4, I had to go up 5 numbers, because -4 to 0 would only get you to 4, plus 1 more is 5. 1 to 6, that also is adding 5. It works all the way across. So yes, this is arithmetic. And the next two terms, if I add 5 again, 16 plus 5 is going to give me 21. And then add 5 again, that will give me 26. This one we're going down from one number to the next. From 52 to 49 we went down 3. 49 minus 3 again is 46. Yes, this pattern works, so yes, this is arithmetic. And our next two terms, if we subtract 3, 40 minus 3 is going to give us 37. And then subtract 3 again, and be at 34. The next two, 3 to 5, we're adding 2. 5 to 9, we're adding 4. 9 to 15, we're adding 6. You guys, you see a pattern here, 2, 4, 6, 8, but is it the same pattern every time? Like when we graphed a line, we had the same pattern, like our slope, rise over run, rise over run, rise over run. It has to be the same pattern. This one rises 2, then rises 4, then rises 8. That's not going to work. So no, this is not arithmetic. And the last one, from 1 to 4, we're going up 3. From 4 to 9, we're going up 5. So right there we can stop and already see that, no, this is not arithmetic. Alright, now we are given the formula for an arithmetic sequence, simply in the form y equals mx plus b. They just flipped around here, our two terms. This would be like mx and then plus b. So just so you know, it really is in the form y equals mx plus b. But regardless, they're asking you to find the first 5 terms and then the term named. So I'm going to make a little chart here so it's easy for me to list all of my numbers. I'm going to find the first 5 terms, so 1, 2, 3, 4, 5. And then we're going to also find when a is 21, or when the number is 21. So we're also going to plug in a 21. So first I'm going to plug in a 1. A sub n just means, hey, for a, what number are we going to plug in for n? See how n matches here? We're going to first plug in a 1 for n, then a 2, 3, 4, 5, and then when n is 21. So first when it's a 1, we have -24 minus 10 times 1. Well, 10 times 1 is still 10, and it's negative. So these are all negative, that's a -34. Then we're going to plug in a 3, or not a 3, a 2. -24 minus 10 times 2. Well, 10 times 2 is 20, so negative 24 and a negative 20, that's negative 44. Then I'm going to plug in a 3. Negative 24 minus 10 times 3. Well, 10 times 3 is 30. So total here we have negative 54. Some of you might notice that you see a pattern, 34, 44, 54. You can assume, because it's a pattern, an arithmetic sequence, the pattern will continue. So then would be negative 64 and negative 74. However, we don't know the pattern all the way unless you did 20 more times here. So instead I'm just going to plug in a 21. Negative 24 minus 10 times 21. So negative 24 minus 10 times 21, well 21 10 times is 210. So altogether that's negative 234. Yes, you can use your calculator if you have questions, but we're just plugging in the first 5 terms, so 1, 2, 3, 4, 5, and then the 21st term. This one, we're still going to find the first 5 terms. So I'm going to list here 1, 2, 3, 4, 5, but then we also want the 12th term, because that's the term they told us to plug in. So here's our equation. First we're going to plug in a 1 for n. 31 plus 4 times 1. Well, this is just 31 plus 4 times 1 is just 4. So that gives us 35. Then I'm going to plug in a 2. 31 plus 4 times 2. Well, 4 times 2 is 8. So 31 plus 8 is 39. Then you guys can see what's going to happen. Every time you're just adding another 4 here, and that works. 35 plus 4 is 39. Plus 4 more would give you 43. Plus 4 more is 47. Plus 4 more will give you 50. And then we also need to plug in a 12. 4 times 12, if you're not sure, again, use your calculator. Well, 4 times 10 is 40. 4 times 2 is 12. So 40 and 12 give you 52. And then for a grand total here, we add those up. 30, 50, 83. So we found the first 5 terms and the term named, the 12th term. Now we're going to do the same thing, but with geometric sequences. I don't know why this is way down here. There you go. What does a geometric sequence look like? Well, a times b to the power of x. We learned this equation before, a times b to the power of x. This is when we graphed exponential growth and exponential decay functions. So these look something like this. And we had close, and then they drastically get really big. So these functions are either multiplying or dividing over and over and over again. So ratio or multiple, meaning divide or multiply. So these ones tell whether it's arithmetic or geometric. Then write the next term. So only one extra term. So first, I wanted to see what my pattern is. 3, 6, 9, 12, 15. This one, every time we're adding 3. And it works all the way across. So we're adding or subtracting. That means it's arithmetic. And the next term, after 15 plus 3 more, would give you 18. Here we're getting smaller, so we're either subtracting or dividing. Well, these are getting small really quick. So if I subtract, it's not going to work the same thing all the way across. So if I divide, it's hard to tell up here, but 16 divided by what is 8? Well, divided by 2. 32 divided by 2 is 16. It works all the way across, so this is what we call geometric. And then if I divide by 2 again, 8 divided by 2 would give me 4. Alright, next 1 to 5 to 25 to 125 to 625. We have 1 to 5. You could add 5, but if I add 5 again, that's not going to work. So instead, we would be multiplying by 5. 5 times 25, yep. 5 times 5 is 25. 5 quarters is 125. So this is also geometric because we're multiplying or dividing. So this one's a little tough. If I multiply by 5 again, 625 times 5, you can write it out or use your calculator. 5 times 5 is 25. 5 times 2 is 10, 11, 12. 6 times 5 is 30, 31. 3,125. Alright, last one. From 4 to 12 to 36 to 108 to 324. So just looking at the numbers, not the negative, positive, negative, positive, negative. From 4 to 12, we're multiplying by 3. 12 to 36, that works to multiply by 3. It works all the way across. But from negative 4 to 12, we'd have to multiply by a negative 3. Well, negative times a negative makes a positive. Good. 12 times 3 is not negative 36. So every time here, instead of multiplying by 3, we're multiplying by a negative 3, which is okay. That is still, not arithmetic, because we're multiplying. This is a geometric sequence. And then the next term of the sequence, it goes negative, positive, negative, positive, negative. So if I'm multiplying by a negative 3 again, those are going to make a positive. Well, 324 times 3. Negative 324 times negative 3 gives me 972. Alright. These next two, it says, given the formula for a geometric sequence, find the first 3 terms and the 8th term. So again, you can make a little table if you'd like for the first 3 terms and the 8th term. I'm just leaving a space so you know the pattern doesn't continue. There's a bunch of numbers missing. So first I'm going to plug in 1. And notice this whole part here is the exponent. So 1 minus 1 is 0. So I have 2 times 3 to the power of 0. Well, anything to the power of 0 is 1. So I have 2 times 1, which is 2. Then I'm going to plug in a 2. So I have 2 times 3 to the power of 2 minus 1. Well, 2 minus 1 is 1. So 3 to the power of 1 is just 3. And 2 times 3 is 6. And then the next one, 2 times 3 to the power of 3 minus 1. 3 minus 1 is 2. Well, 3 squared, 3 times 3 is 9. And 2 times 9 is 18. So notice each time we're multiplying by 3. So now if I plug in 8, 2 times 3 to the power of 8 minus 1 is 7. So 3 to the power of 7, 3, again this means to the power of 7, equal to 2187. But then we need to multiply by 2. I'm going to just hit times 2. Gives me 4,374. Alright, let's do the same thing with the next one. Make a little table so we can find our first, second, third, and 8th term. 1, 2, 3, and 8 because they asked for the 8th term. So first I'm going to plug in a 1 for the n. So we have negative 4 times 2 to the power of 1 minus 1 is 0. Well, anything to the power of 0 is 1. So negative 4 times 1 is just negative 4. Then if I plug in a 2, negative 4 times 2 to the power of 2 minus 1, which is 1. Well, that's just negative 4 times 2, which is negative 8. Then our next term, negative 4 times 2 to the power of 3 minus 1 is 2. Well, 2 squared, 2 times 2 is 4. So negative 4 times negative 4 is negative 16. And then last, plugging in an 8, negative 4 times 2 to the power of 8 minus 1 is 7. Well, 2 to the power of 7, not quite sure, 2 to the power of 7 gives me 128, but then multiply by negative 4, we get negative 512. Last two here are multiple choice questions. Which equation would generate the following sequence? Now there's a couple things you could do. You could plug in a 1 into all these and see if you get 5, and then a 2, and then a 3, and then a 4, because for the first term, second term, third term, and fourth term. Or you could just think of what type of pattern is this first. For example, from 5 to 15 to 45 to 135, we're multiplying. So I know this is not going to be an arithmetic sequence, so I can automatically rule out A. All the rest have some sort of multiplication in there. So just like our table before, our first term was 5. So if I plug in a 1, I should get out a 5. So this one, 5 times 3 to the power of 1 minus 1, which is just 0. So 3 to the power of 0 is just 1. So we have 5 times 1, which is 5. So this one, first term, is looking good. Now we're going to try the next one. 3 times 5 to the power of 1 minus 1. Well, again, that's 0, so that's really 3 times 5 to the power of 0, which is just 1. 3 times 1 is just 3. That's not our first term, so I know that can't be the right answer, because when I plugged in a 1, I didn't get a 5. And then the last one here, 15, and then 1 minus 1 is 0. Well, 15 to the power of 0 is just 1. So right away, I only had to plug in one number after I knew it was an exponential function or a geometric function. If you wanted to plug in a 2, a 3, and a 4, you could, but we already know we narrowed it down. Same thing here, but we're given the sequence. What function will this create? So I'm just going to make a table and plug in a 1 first. If I plug in a 1, negative 14 plus 3 times 1, well, 3 times 1 is just 3. So negative 14 plus 3 is negative 11, which matches C and A. So I can eliminate the other two options. Next, I'm either going to get positive 8 or negative 8. So if I plug in a 2, negative 14 plus 3 times 2, well, 3 times 2 is 6. Oops. Negative 14 plus 6, there's more negatives, it should give you a negative 8. So here's our pattern, negative 11, negative 8. Hopefully next you get a negative 5 and a negative 2, and so on. Alright, the second part of our lesson today is on graphing linear equations. This part should be a review because you've done most of this before. We know how to find slope counting rise over run, and using 2 points, x1, y1, x2, y2, we can plug it into our equation. Our third way is simply using our slope form, y equals mx plus b. So, a couple things we learned. This slope from left to right, we call this a positive slope, going up. This one from left to right is going down, that's a negative slope. Walking straight flat across would be a slope of 0. And then this up and down line, vertical line, there's no slope there. You can't walk across that line. You would die. That is called undefined. Alright, so let's take a look at some problems. Find the slope of the line. So I'm simply going to start by labeling my points. XY first point, XY second point. And then plug them into my slope formula. Y2 minus Y1 on the top. So negative 7 minus a negative 7. On the bottom, x2 minus x1, or 0 minus a negative 3. Hopefully you know two negatives here make a positive. So we're left with negative 7 plus 7 is just 0. There's nothing there. 0 plus 3 is 3. So it's okay to have a 0 on the top, so this is just 0. Alright, next one, same thing. Label your points xy first point, xy second point, and plug in what we know. y2 minus y1, so 5 minus 4, and then on the bottom x2 minus x1, or 9 minus 3. 5 minus 4 is 1, 9 minus 3 is 6. There's nothing we can simplify there, so our answer is 1 over 6, or 1/6. Alright, here's xy first point, xy second point, and plug them in. Oh, where'd our slope formula go? There it is. y2 minus y1, so 2 minus a negative 4. Two negatives making a positive. That's where people make mistakes. And then x2 minus x1. So on the top, 2 plus 4 in the numerator is 6. Negative 2 minus 4, same sign, they're all negative, so it's a negative 6 as well. 4 and 2 more, all negatives. 6 divided by 6 is just 1, but it's negative. And then last one, xy first point, xy second point. So to find our slope, we're going to do y2 minus y1, negative 3 minus 4. On the bottom, negative 10 minus another negative 10, again making a positive. So we have negative 3 minus 4. Same sign, let's add them up. That's a total of negative 7. Negative 10 and a positive 10 make 0. So this is one of those that you can't have a slope. 0 would be horizontal. That's 0 divided by a number. That's okay. But if it's not okay, that's what we call undefined. So this is not okay. This is 0 in the denominator. So this is undefined, meaning it's a vertical line. Alright, our next couple questions are simply on finding the slope and the y-intercept. Or in the form y equals mx plus b, we're finding m, and b, our y-intercept. So this one is already in the form y equals mx plus b. So m, our slope, is 10, and b, our y-intercept, is negative 6. Same thing here. We have y equals 1x, it's really 1, plus b, or mx plus b. We'll change that here. So really, there's no b here, so I can assume it's 0. So my m, or my slope, is 1. If you want to make it a fraction, you can. And b is 0. Now we need to do the same thing here, but these ones are not solved for y, so we just need to solve for y first. So we need y by itself. We're going to get rid of this 3x. I'm going to subtract 3x because it's a positive. Oops, I just put add. Subtract. So those eliminate, and I have negative 2y equal to negative 3x plus 16. And then these are touching, that's multiplied, so we need to divide by negative 2. So those eliminate, and we have y equals, two negatives make a positive. And then 16 divided by negative 2 is negative 8. So they wanted to know m and b, or the slope and the y-intercept. So m is 3 over 2. Because this is now in the form y equals mx plus b, b is negative 8. Last one like this. We need to move this x portion over to the other side. It's a positive, so I'm going to subtract 1/5 x. So I have a negative y, don't forget the negative there, a negative 1/5 x, and a positive 11. And then this is really a negative 1, so the opposite of multiplying by negative 1 would be to divide by -1. So we have y equals, two negatives here make a positive. 1/5 divided by 1 is still 1/5. The negative doesn't do anything but change the negative to a positive. And then minus 11 divided by 1 is still just 11. So in this case, m, or our slope, is 1/5, and b, our y-intercept, is -11. Our last way we need to make sure we know how to do is to graph this when it is in the form y equals mx plus b. So m is -3/4, b is 1. So think way back to graphing equations. B is where we begin on our y-axis. So we're going to begin at 1. And then our slope is how we move, rise over run. So up and down first. So this is negative. We're going to go from this point, not from the middle, from the point, down 1, 2, 3. And then +4 is to the right, 1, 2, 3, 4. We could go down 3 again, but 4 to the right would be off the graph. So instead of going down and right, we can now also go the opposite, up 3 and 4 to the left. So some of you have been just doing this. We need to make sure to extend our line all the way out in both directions, all the way to both sides of the graph. All right, let's try one more. We need to solve this one for y, though, first. So I'm going to move this 2x to the other side. I'm going to add 2x. And those eliminate. We have 3y equal to 2x minus 9. And we want y by itself, so I'm going to divide everything by 3. So those eliminate, and we have y equal to 2/3 x minus 9 divided by 3, which is 3. So from this equation, m in front of the x is 2/3, and b is -3. So let's begin on our y-axis at -3. And our slope is rise over run. They're both positive, so up 2 and 3 to the right. Up 2, 3 to the right. Or the opposite of up and right would be down 2 and 3 to the left. Down 2, 3 to the left. And there's our line. The last two here are the same thing. They're just what we call direct variation equations, meaning our y-intercept, or b, is 0. This is in the form y equals mx plus b. It's just going through the origin. It's beginning at 0. It's what we call proportional or direct variation. M then here is -1 really. So as a fraction though, that's -1 over 1. So rise over run for our slope, we're really going down and right. Down and right. Down 1, 1 to the right. Remember, if your slope's not a fraction, always make it a fraction so you can count rise over run. Notice I also went the opposite direction. Instead of down and right, I also went up and left. All right, last one, we need to solve for y. So I'm going to subtract this 5x over to the other side. So we have y equals -5x plus 0. There's nothing added or subtracted to the end there, so that means I'm beginning at 0. And then m as a fraction is -5 over 1. So that means rise over run down first, 1, 2, 3, 4, 5, and over 1. So instead of going down and right, we can also go up 1, 2, 3, 4, 5, and left. So there we go. If you have other questions, I know we went through this a little bit quick, please make sure to ask. but you will get your homework here shortly. The front side is sequences, and the back side is slope. You get to move 10 yards for each side on the football wall, so total you get to move 20 yards down the field as soon as you turn this in.